So in order for a radical fraction to be simplified completely, there cannot be a radical in the denominator. That root is not allowed to stay in the denominator. I'm going to need to rationalize it, but just multiplying by root 7 times root 7 over root 7 is not going to work. It's not going to get rid of the root in the denominator. And so what I'm going to have to do is multiply by what's called the conjugate. The conjugate, all that does is changes the middle sign. So if this is the quantity root 7 plus 1, I need to multiply by the quantity root 7 minus 1. Essentially, it's what I'm multiplying by to get rid of any radicals. So the conjugate in this case is root 7 minus 1. So I'm going to multiply the numerator and the denominator by root 7 minus 1. In the numerator, I'm distributing a 1. So 1 times root 7 is root 7. Distributing in a 1 doesn't change anything. 1 times a negative 1 stays minus 1. In the denominator, however, I've got some FOILing to do. So I'm going to take this one step at a time. First times first is root 7 times root 7. Now let's think about root 7 times root 7. When you're multiplying the radicals, you combine what's underneath. So this is root 7 times 7, which is 49. The square root of 49 is 7. So the first term is 7. Outer times outer. Root 7 times negative 1 is just a minus root 7. Minus 1 root 7. Minus root 7. Inner times inner. 1 times root 7 is plus 1 root 7 or plus root 7. And then last times last is 1 times negative 1, which is minus 1. So when I look at this denominator, I'm specifically looking at negative root 7 plus root 7. Those are going to cancel each other out. One's a minus, one's a positive. They cancel each other out completely. So root 7 minus 1 in the numerator over 7 minus 1, which is 6, in the denominator. And this is as simplified as possible. Nothing else cancels out, and the root is in the numerator where it's allowed to be. Number 10 says root 10 over 7 minus root 2. So I don't like the root in the denominator. And because of that subtraction, I can't just cancel the 10 and the 2. I'm going to have to do the same process as what I just did. So this denominator is 7 minus root 2. The conjugate of 7 minus root 2 is 7 plus root 2. So I'm going to multiply the numerator and the denominator by 7 plus root 2. I just have to be very careful with my radical rules. So in the numerator, I am distributing a root 10 to a 7 and a root 2. So root 10 times 7, because that 7 is not underneath the square root, is just 7 root 10. It does not become root 70 because that 7's not underneath the root. However, the root 10 times the root 2 is, because they are both underneath the radical, the same thing as the square root of 20. So plus the square root of 20. Over, and I guess we can simplify it now, or whatever. You are going to need to simplify the square root of 20, because 20 is the same thing as 4 and 5, so this would be 2 root 5. So let's go ahead and do that. Root plus root 20 is simplified to be plus 2 root 5, which they would want you to do. Okay, and then in the denominator, 7 times 7, easy enough, 49. Outer times outer, 7 times a positive root 2. I'm not even going to write that down, because inner times inner is a negative root 2 times 7. And if you've got the positive and the negative, they're going to cancel each other out. And then my last term is minus root 2 times root 2. So root 2 times root 2, just like how root 7 times root 7 ended up being 7, it is going to end up being 2. Root 2 times root 2 is root 4, which is 2. So 49 minus 2. So in the numerator, because those are not like terms or like radicals, I can't combine them. 7 root 10 plus 2 root 5. And then in the denominator, 49 minus 2 is 47. So that is the whole entire final answer, because the numerator cannot be combined and those roots are allowed to be in the numerator.